Hey everyone, I'm Tatiana, a Docker captain, DevOps consultant, and cloud engineer with real-world experience automating and scaling infrastructure. On this channel, we dive into Docker, Terraform, Kubernetes, and everything cloud to help you build smarter, deploy faster, and create systems that don't crumble under pressure. If you are preparing for a cloud engineer or DevOps engineer interview in 2025, Docker is non-negotiable. It comes up every single time. Today, we are going through 10 Docker questions you are very likely to face and how to answer them clearly and confidently. But before we set sail into the questions, let's quickly drop anchor and cover what Docker actually is, just to make sure we are all aligned on the basics. Docker is a platform that lets you run applications in isolated environments called containers. These containers can run consistently across different environments, your laptop, a test server, production, without running into problems that only appear outside your local setup. In real-world projects and DevOps roles, Docker is almost everywhere for app development, testing, CI/CD pipelines, and cloud deployments. Alright, now that we're clear on what Docker is, let's jump into the real interview questions you might face. Question 1. What's the difference between an image and a container? And what happens if you delete the image? A question that checks real understanding, not just usage. A Docker image is like a frozen recipe for your application. It includes everything needed to run it: code, libraries, environment settings. A container is what you get when Docker takes that image and actually runs it, like turning the recipe into a real running dish. The image is read-only and reusable. The container has its own writable layer and lives as an isolated process. If you delete the image but the container is already running, it keeps working because the image is already loaded into memory. But if you stop that container and try to restart it, Docker won't find the image and the restart will fail. And pro tip: take your images properly, my app latest, my app version 1.2, and regularly prune unused ones, but avoid deleting images used by running containers. Question 2. What actually happens when you run Docker run? This sounds simple, but your answer reveals how well you understand Docker internals. When I run, Docker first checks if the image exists locally. If not, it pulls it from a registry like Docker Hub. Then it creates a container, which is basically an isolated process with its own file system, networking, and resources. Docker sets up isolation using Linux namespaces and cgroups. Finally, it executes the default command defined in the image. For example, running docker run nginx pulls the nginx image if it's not local, creates a container, and starts the nginx server inside that isolated environment. And pro tip: use --rm with docker run to automatically clean up the container after it exits, so your system doesn't get cluttered with stopped containers. Question 3. Copy versus add. What's the difference and when would you use each? Shows whether you write clean and secure Docker files. Both copy and add move files into a Docker image. Copy simply copies files and folders. No surprises. Add does more. It can unpack compressed files like .tar, .kz, and download files from URLs. Because add has extra behavior that's not always obvious, I prefer copy for clarity and only use add when I specifically need those extra features. For example, using copy for your app code is safer. Use add only if you need to extract a tarball directly into the image. And pro tip, simplicity is security. Prefer copy unless you have a very good reason. Question 4. What's a multi-stage build and when would you use it? This question tests if you know how to create clean, production-ready images. A multi-stage build is when you use multiple from statements in your Docker file. The first stage does heavy work, installing dependencies, building code. The final stage copies only the necessary artifacts into a clean, minimal base image. This reduces image size and eliminates unnecessary files and tools from production images. For example, in a Node.js app, you can build everything in one stage using all the necessary tools, and then copy only the final dist folder into a lightweight production image. And pro tip, smaller images equals faster deployments plus fewer vulnerabilities. Next up, question 5. CMD versus entry point. How do they work together? Entry point defines what runs the main executable. CMD gives the default arguments. When you use Docker run, the arguments you pass override CMD, but not entry point. Together, they give you a flexible default setup that you can still tweak at runtime. Here's a simple example. This always runs Nginx unless you explicitly override the entry point. And pro tip, want full control at runtime? Use only CMD and leave out entry point. Question 6. Volumes versus bind mounts. Which would you use in production and why? This question tests how you think about data persistence. In production, I prefer Docker-managed volumes. Volumes are isolated from the host OS, easier to back up, and more stable over time. Bind mounts depend on host paths, which makes them fragile and environment-specific. Bind mounts are great for local development, not for production. For example, storing database data like PostgreSQL or MySQL always use a named Docker volume. And pro tip, volumes are portable, reliable, and more future-proof across hosts and clusters. Question 7. How does networking between containers work? A real-world question for microservices. By default, Docker connects containers to a bridge network where they get private IP addresses. However, they can only reach each other by IP unless you create a user-defined network. In a user-defined bridge network, containers can communicate by name, which simplifies service discovery. For example, if two containers like your app and a database are in the same user-defined Docker network, your app can simply connect to database using the container name as a hostname, not an IP address. Docker's internal DNS automatically resolves the container name inside that network, so you don't need to hardcode any IPs. And pro tip, always use user-defined networks. The default bridge network doesn't support automatic name-based discovery and can lead to frustrating connection issues. Question 8. How do you reduce Docker image size and why should you care? This shows if you care about performance and security. Reducing image size speeds up builds, deployments, and improves security. I start with a minimal base image like Alpine 3.21.3, Python 3.12 Slim, Bookworm, or Node 20.13.1 Alpine. I combine run instructions to reduce layers and clean up any temp files or caches. I always use a .docker-ignore file to exclude things like .git, node modules, and test data. And for complex builds, I use multi-stage builds to separate build tools from the final runtime. For example, a Node.js app image can shrink from 1.2 gigs to under 200 megabytes by switching to Node 20.13.1 Alpine and cleaning up properly. And pro tip, smaller images equals faster pipelines, quicker deploys, and fewer security issues. Question 9. What is BuildKit and why use it? This tests if you stay updated with Docker improvements. BuildKit is Docker's modern build engine that significantly improves performance, security, and flexibility. It enables parallel execution of independent build steps, advanced caching mechanisms, and secure handling of secrets during builds. BuildKit also supports features like multi-platform builds and efficient storage management. In modern Docker versions, BuildKit is enabled by default, so you don't need to configure anything. But if you are on an older setup, you can still enable it by setting Docker BuildKit equals 1 or updating the Docker daemon config. For example, with BuildKit, multi-stage builds can run steps in parallel, reducing build times significantly. And pro tip, always leverage BuildKit for faster, more secure, and efficient Docker builds. And finally, question 10. How do you handle sensitive data like secrets in Docker? Security is a huge concern. They want to hear your real-world strategy. I never hard-code secrets into Docker files or images. For local runs, I pass secrets as environment variables, either inline or via a .env file. If I use a .env file, I make sure to add it to .dockerignore, so it doesn't accidentally get copied into the image. In production, I use secret management tools like HashiCorp Vault, AWS Secrets Manager, or Kubernetes Secrets to inject secrets at runtime. Secrets should always come from outside the image, not baked inside. For example, pass database passwords using environment variables in staging and HashiCorp Vault in production. And pro tip, good secret management equals safer deployments and easier key rotations. And that's all 10 questions. These are not trick questions. They test how you think and how you build real-world systems. If you liked it, leave a like. It would honestly make me so happy. Subscribe if you want to go deeper into DevOps, cloud, and automation, and drop a comment with the next topic you'd like to see. And don't forget to join our Discord community. The link's in the description, where you can ask questions, share your projects, and connect with other DevOps engineers. See you in the next one. Keep learning, keep building, and keep shipping awesome projects.